next problem we're taking a look at is from a 2012 question from University College of London. Now we have a variable x that follows a uniform distribution over the interval 0, 1. What we want here is to find the PDF of y equals e to the x. So we have a new random variable y that's a function of the old variable x. We want to find the probability density function of y. So here we know a formula that the probability density function of y at the point y is fx of h of y and multiplied by the absolute value of the derivative of h of y with respect to dy. So what's this? What's h? You have y equals e to the x. So suppose y is a number and x is a number too. We have to solve this relation for x. If we take logarithms in both members, we have a ln of y equals a ln of e of x of e to the x power. So a ln of y equals x. So we have x equals h of y. You understand that the function h of y we have here is h of y is actually a ln of y. So it's easy now to substitute h into our formula and find the probability density function of y. We have fx of ln y multiplied by the absolute value of the derivative of ln y with respect to y. This is fx of ln y, and of course this derivative here is the absolute value of 1 over y. Now we only suppose that y is positive. Y is positive because y equals e to the x, and we know that it's always positive, so y must be positive. And now we have to remember what's the probability density function here of x. If you remember, because you have the uniform probability here, fx of x equals to 1 if x is between 0 and 1 and 0 otherwise. How can we combine now these two? Remember, if fx of ln y is 1, then it's 1 multiplied by 1 over y. If it's 0, then the product is 0. But we have to consider one more thing here, that let's find fx of ln y. If ln y is between 0 and 1, then if ln y is between 0 and 1, then fx of ln y is 1 and fx of ln y is 0 otherwise. Now if you try to solve that for y, so to solve in terms of y, we have you can take ln of e to be 1, ln of y in the middle, and ln of 1 is 0. From here we get 1 less than y less than e. So let's see all these together to make a composite thing now. So we have fy of y equals to, if this is 1, the product is 1 over y, and that case is valid when ln of y is between 0 and 1, which is the same as 1 is less than y less than e. So here we have 1 over y for y between 1 and e, and otherwise it's 0. So if you multiply 0 by something, you get 0, 2. This is the answer.